Hi everyone, I'm Di Yang from India. I'm glad to present our work in collaboration with Toyota, LAC, Latent Action Compensation for Skeleton-Based Action Segmentation. This is a joint work with Yaohui Wang, Antisa Danchova, Quan Kong, Lorenzo Galatoni, Gianpiero Francesca, and François Bremont. Action recognition based on human skeleton data had witnessed increasing attention due to its robustness to changes in appearances, environments, and viewpoints. To deal with action segmentation tasks that require recognizing composable actions in untrimmed videos, current approaches decouple this problem by first extracting local features from skeleton sequences and then processing them by a temporal model to classify frame-wise actions. However, their performances remain limited as the extracted features cannot sufficiently express composable actions. Hence, in this work, we propose latent action compensation (LAC), a novel self-supervised framework aiming at learning from synthesized composable actions for skeleton-based action segmentation. LAC aims at training a more effective skeleton encoder endowed with strong representation ability of subtle action details. LAC is firstly composed a novel generation module towards synthesizing new sequences. The generative module is an autoencoder for skeleton sequences to learn and combine the high-level motions of multiple skeleton sequences. We introduce a linear action decomposition mechanism to learn an action dictionary, which is an orthogonal basis where each vector represents a primitive motion of static transformation in the representation space. New composed motions can be synthesized by simply performing arithmetic on latent representations learned from multiple input skeleton sequences. Then, LAC incorporates a contrastive module for learning skeleton representations in both sequence and frame spaces, leveraging such synthesized sequences, which have large diversity and complexity. The sole-trained visual encoder on a large-scale skeleton dataset can have a strong representation power and can be effectively transferred onto frame-wise action segmentation tasks by end-to-end retraining without need for additional temporal models. We conduct extensive experiments to evaluate our LAC on 3 action segmentation datasets: Toyota Smart Home Untrimmed, Charades, and PKU MMD, following the linear and fine-tuning evaluation settings with transfer learning. From these transfer learning results, we conclude that collecting a large-scale trimmed skeleton dataset without the need for action annotation can be beneficial to downstream segmentation tasks for untrimmed videos. And we can outperform previous state-of-the-art performance. Here is the inference demo on Toyota Smart Home Untrimmed dataset. It shows that our method works better compared to previous skeleton-based method in the challenging case. To demonstrate the motion features have been effectively learned, we first evaluate the generation quality of LAC by conducting action compensation. Here are generation results on real-world videos. We also conduct interpretation of decomposed motion directions by the latent action decomposition mechanism in LAC to visualize the learned primitive motions. In conclusion, in this paper, we present LAC, a novel self-supervised action representation learning framework for the setting of skeleton action segmentation. We show that high-level primitive motions of skeleton sequences can be learned and linearly combined using an orthogonal basis in the latent space. Future work will extend our generative approach to RGB videos in order to improve the capturing of the object information, which can be crucial and complementary to the skeleton-based model. More details can be found in the paper. Thank you for your attention.